Assalamualaikum and good morning to everyone. My name is Muhammad Akmal Matno, and today we will do a video presentation for pressure in pipe experiment topic. But first, we will introduce our group members. We start with first group members, which is Amin.
Okay, Assalamualaikum. My name is Muhammad Amin SHAFIQ bin Muhammad RAMLI. And now I will move to our next group members.
Assalamualaikum. My name is Muhammad HAZIM bin AHMAD ZULKAFLI.
Hey, Assalamualaikum. Muhammad Aris bin JOHARI.
My name is MANSOR.
We will start with our presentation first. We start with introduction. I will share the content first.
Okay, thank you Muhammad Akmal. Now I'm going to present our project. Okay, firstly, I'm going to tell general about our topic, fertigation. Fertigation is widely used in farming industry. This method allows growers to save time, resources and effort by completing two methods. There is fertilization and irrigation in a time. Okay, now is one way of growing vegetable with advantages of minimizing amount of water. That's mean this is will optimizing water consumption for farmer. The second one is there are two types of pipe configuration be applied for water process, namely straight line or closed loop. And for the third one is we are going to use two different configuration, give variation in terms of flow rate as well as the volume of water received by each plant. Okay, next, I'm going to tell about our objective for our project. Firstly, this project is we are able to perform experimental and simulations flow exercise in hose pipe. That means there are two types of hose pipe. And the second one is we are able to analyze pressure variation in hose pipe over a specific length with two different configurations. And the third one is we are able to report the finding in appropriate approach in our project. And now this is our equipment that we use into shelter our project. Firstly, we use the single connector for our single pipe, and now we are going, our equipment is T connector. That's mean for the second type of pipes. And next is hose pipe and measurement cup for our measure water, and hose clip, and the lastly is stopwatch to record our time. Okay, that's all for my part. Now I'm going to pass to my friends.
Assalamualaikum. My name is Muhammad HAZIM bin Ahmad ZULKAFLI. I will present about the experiment that we perform. First, experiment 1 is to determine the pressure of water jet. We use the hose pipe that has the diameter of 16 mm and open the pressure and let it flow, as you can see in the slide. So from that we collect the data. The Z of the experiment is 1.4 meter, and the time taken we get to get 2000 milliliter is 16 seconds. Next, I will tell about the experiment 2, which is straight line hose pipe. First, we prepare the hose pipe in a straight line and we make 5 holes all the way at the straight hose pipe. Each hose, each hole we put the single connector, and the hole size is 3 mm. From this experiment, we can get the volume of water flow at every hole and the time taken. Next, I will go to experiment 3, which is closed loop hose pipe. We prepare the closed loop using T connector and at the round part of the hose pipe, we make 10 hole, and at each hole we put the single connector. From this experiment, we also can determine the volume and the time taken of the water that flow at every hole. Okay, next, let's see to the result and data. For the water jet, we put the length 1.4 for Z, and we get 17 seconds for the water until it reach 2000 milliliter. And for the experiment 2, straight line, the time taken for the water to reach 700 milliliter is 60 seconds. And for the closed loop, time taken to the water to reach 500 milliliter is 60 seconds. Okay, next we go to the calculation part. For the first experiment, we can find the flow rate, velocity, and pressure of the water. First, we calculate the area of the pipe, which is 16 mm, and use the formula of pi d square per 4, and we get 2.011 times 10 power of -4. And then the flow rate, we use the formula V volume per time taken, and we get 1.25 times 10 power of -4 meter cube. And for the velocity of water, we use the formula flow rate per area, and we get 0.6216 meter per second. And for the pressure, we use the Bernoulli equation and we get 13.92 kilopascal. Next, for the experiment 2, we can determine the area, flow rate, and velocity, also the pressure. And for the area, we get 7.0686 times 10 power of -6. And the flow rate, we get 1.17 times 10 power of -5 meter cube. And velocity, we get 1.6552 meter per second. And for the pressure, we get 6.27 kilopascal. And then finally, for the experiment 3, we use the diameter of 3 mm at each hole. So the volume we get 500 milliliter and time taken is 60 seconds as shown in the result data. So we calculate the area and we get the area is 7.0686 times 10 power of -6. And the flow rate, we get 8.33 times 10 power of -6 meter cube. And the velocity, we get 1.1784 meter per second. And finally, for the pressure, we get 5,599.55 Pascal, and we convert to kilopascal, we get 5.59 kilopascal. Okay, that's all from me. Next, I will pass to my group member.
Alright. My name is Muhammad Aris. I will explain about simulation flow through pipe. Right. For the purpose of this tutorial is to illustrate the setup and solution of 3D turbulent flow in a pipe. The pipe network are common in any engineering industry. It is important to know the development of a flow at the pipe entrance and pressure drop taking place along the pipe length. The flow of fluid in pipe is widely studied fluid mechanics problem. The correlation for entry length and pressure drop are available in terms of flow Reynolds number. Okay, this is the geometry for pipe. Then next. Right. Okay, this is our part of drawing the missing. And then next, this is our solution of graph. Then next, this is our result. Then next, right. Okay, I will passing to Mr. Akmal to continue for simulation 90 degree.
Thank you, Mr. Haris. My name is Muhammad Akmal, and right now I'm going to explain about the simulation for 90-degree bend pipe. First one is the geometry of the project, which is 90-degree bend pipe. We can sketch by using the diameter of 500 millimeter for vertical length and 200 millimeter for horizontal length. And the diameter of the pipe is 10 mm for inlet and outlet. And the bend we using fillet for 15 millimeter. Next, we go for meshing part, which is we using 4 layer of mesh, and then we name every part first. For example, this one is inlet, first one, and second one here is in section wall. Here we got bend wall, and here out section wall, and lastly we have outlet here. Okay, this is the example of solution. After we put all the data, and we can calculate the result that we need, which is for right now is the flow coming from inlet to outlet. This is the result that we get after we do calculation by using this ANSYS analysis. So this one is P2, which is outlet velocity. We get 5.5716. That's all for me. And now I'm passed to the next presenter, which is Mr. Hazim.
Akmal. From this experiment, we discussed about the relationship between pressure and velocity. The velocity affects the pressure. When the velocity high speed, the pressure will decrease. We call as Bernoulli principle. The meter of pipe affect the pressure in the pipe. The velocity will high when the pipe is small. Length of the pipe also affect the pressure and velocity. Yes. conclusion for the experiment is the experiment was conducted to measure the maximum flow in the pipe. We success to achieve the objective of the experiment and be able to apply Bernoulli principle.
That's all from us. We are from Group C. Thank you very much.